Hello everyone. So in this sections we will start with chapter 3, and in this video we will discuss about the classification of matter and the states of matter. So to begin with, let's revise a little bit. What is matter? Matter is anything that surrounds us. Anything that you look around, that you feel around, is a matter, right? So matter could be classified into two different types. So one could be pure substance, pure, and another one could be mixture. So we can classify all of our matters into these two categories. So let's start with what is pure substance. Pure substances that has a fixed or definite compositions. That means it's made up of only one type of, you can call it particle. We're going to talk about in details later. So here's an example. Pure substance, let's say you have aluminum foil in your kitchen, right? So what it is made up of? It is made up of only aluminum. So all the aluminum atoms comes together to make that aluminum foil. So it has only one type of particle, that is aluminum, and there is nothing else is in there. So that's a pure substance. What is another example of pure substance? You can call it water. Let's say you have a completely pure water, like it's not contaminated with anything. Uh, the water is made up of a particle. That particle has a definite compositions. Um, we will talk about that in a few videos, which has H2O. You have heard about this or known about this. So what does this mean? Water, in the particle of water, you have two hydrogen atom and one oxygen atom, and that is definite. Like it's not gonna be H3O or H4O or something like that. It's always two hydrogen and one oxygen, and that's what the water is made up of. So water and aluminum foil both are pure substances. So we can categorize the pure substances into two different categories. One is elements, another one is compounds. So in this particular example, the two example where we talked about it, can you guys tell which one is elements and which one is compound? Yep. So our aluminum foil is made up of aluminum, right? So it is an element. So elements are usually made up of only one kind of atoms. So atoms is the smallest particle of elements. Then compound is made up of two or different type of elements, but with definite compositions. So multiple elements with definite compositions. So what is the example we just talked about? Water. So it has two elements, hydrogen and oxygen, and the composition is 2 to 1, and every particle in the water is made up of H2O. Okay, let's talk about mixture. Mixture is basically crock pot, right? That's just like you dump everything in there, and that's a mixture. So you dump sand with water, that's a sand water mixture. You dump oil and water, that's oil water mixture. So anything that you put together, those are not pure. It's a mixture, right? So mixture can be categorized into two different type. Oh, maybe I'm running out of space here. One is called homogeneous mixture. So homogeneous means it's basically uniform. Okay. Sorry guys. What just happened? Okay, so it's basically a uniform mixture. So what is a uniform mixture? Let's say here's a quick example. One example is milk. So milk is a mixture of fats, vitamins, water, lactose, proteins, a lot of stuffs are in there, right? So but it's a uniform mixture. So what do I mean by uniform mixture? So let's say you drink the top portion of the milk, it tastes or it feels exactly the same as the bottom portion of the milk, right? In case your milk has gone bad, then it's gonna be precipitated, but that's different thing. So the milk is homogeneous, where you have it's made up of multiple different type of substances, but they are all distributed equally. So that's a uniform mixtures. Another uniform mixtures, cocktail. You have water, you have your drink mix, and everything is well distributed. Sugar and everything is very well distributed. So the top portion of the cocktail does not, if it's well mixed, obviously it's gonna taste same as the bottom one, right? So like mixed drink, let's say you make a lemonade, right? But lemonade, so make sure it's filtered, because do you like pulp? So that's an example of homogeneous mixture. So what is that? The next type is heterogeneous mixture. And what is a heterogeneous mixture? A heterogeneous mixture is a mixture, but that's not uniformly distributed. Maybe if you pick a section, maybe the top section is not the same as bottom section. So here is an example. Let's say you like orange juice, guys. Let's say orange juice with pulp. Orange juice with pulp. So what happened if you pour orange juice with pulp? What's gonna happen? All the pulps are gonna settle down on the bottom, and the top portion is just liquidy water and less pulp. So you see the difference? Let's say you did not mix it. So the top is, I'm just putting word here, top is liquidy, right? Is that a term, liquidy? Okay, top is liquidy, more bottom is more pulpy. Bottom is pulpy, right? So that's the difference. Like if I take the top portions here, it's not gonna be as equal as the bottom portion. So that's an example of heterogeneous mixture. So you come across with the mixtures a lot everywhere. So let's say you bought hydrogen peroxide solutions from the store, which is basically a mixture of hydrogen peroxide and water. That's a homogeneous mixture. But if we are talking about just the hydrogen peroxide, let's say you bought pure hydrogen peroxide, that's a compound. Sodium chloride, what is it? Your table salt. So table salt is made up of one sodium atom and one chlorine atom, right? Sugar is a compound, which is a pretty big compound. Its formula is C12H22O11. So it's gonna be, you have 12 carbon atom, 22 hydrogen atom, 11 oxygen atom. They comes together to form a sugar. And your entire sugar is made up of these particles with definite compositions. So this is an example of compounds. All right. So now we're gonna jump into the next concept, which is for exam purposes, I'll ask certain example and ask you which group it belongs. Let's say copper coin. is it's a pure substance, right? It's made up of only copper, and it doesn't have anything else, so it's gonna be an elements, pure substance, elements. So I'll be asking these type of things. Maybe here is another one. Let's say pasta with cheese. What is going to be? It's gonna be our mixture. What kind of mixture would that be? Homogeneous or heterogeneous? I think I would say heterogeneous, because you cannot distribute two solid particles uniformly. Heterogeneous, right? Because sometimes there are more cheese on the top than bottom if you did not mix well, so it's gonna be heterogeneous, right? Pizza. I'm hungry. I'm getting hungry now. Pizza is a heterogeneous mixture. Obviously, there is crust on the outside. There is more cheese inside. There is more bread on the bottom. Top is more pepperoni. So this is a heterogeneous mixture. So pizza is a mixture, and it's a heterogeneous mixture. What else? Coke. Coke is a mixture, but it is mixture of water, sugar, and bunch of other chemicals, caffeine. But it is gonna be homogeneous, right? So it's uniform. So you got the idea. So you should be able to differentiate the classification of classify matters into different categories. Okay, so now we're gonna jump into the next portion, which is states of matter. So every matter exists in three different states: solid, liquid, and gas. So what is a solid? So you guys know what is a solid, right? One example, anything that's like our computer, everything. Ice, solid. Sugar, solid. So everything that you name is mostly solids, right? So what's the uniqueness of the solid? So solid has a definite shape. So it has a definite shape, right? Like, does liquid has a definite shape? It takes the shape of the container. If you pour water into a bottle, it will take the shape of the bottle. If you pour water into the glass, it will take the shape of the glass. So it's molded into the shape of the container. So it takes the shape of the container. Right? How about the gas? Gas doesn't have its own shape either, so it takes the shape of the container. So let's say you pour the helium gas in a tank, then it's gonna be a shape of tank. If you pour the helium gas in a in a balloon, then it's gonna be shape of the balloon. So it's gonna be the shape of the container. What else you can differentiate? How about volume? Solid has a definite volume, right? The volume of solid does not increase or decrease. So if you have a 1 cup of flour, it's gonna stay 1 cup of flour. You cannot make more flour. So same goes for liquid. It has a definite volume, right? So if you bought a gallon of milk from store, when you arrive at your home, you're gonna have still 1 gallon of milk, unless you drink in the car, right? Nobody drinks milk in the car. Did you guys do? Okay, it has a definite volume, because if you bought a gallon of milk and by the time you arrive to your home, then if you have 2 gallons of milk, then you will never go back to grocery store, right? So liquid has a definite volume. Tell me about the gas. Does gas has a definite volume? No, gas does not have a definite volume. So it can fill any container. No, so it fills any container. So you can fill whole tank of helium gas in a big giant balloon. You can fill the whole tank of helium gas. Like if you let it go, it will fill your room, it will fill anything. So gas does not have any volume. You can constrain in a very small volume, or you can expand in a very large volume. So it doesn't have any volumes. Okay, so how about the arrangement of particles? So all the matters are made up of particles, right? So it's made up of small tiny particles. So I'm just gonna draw here, then you guys can generalize statement. So both solid, liquid, and gas are made up of particles. And when we look deeper into it, this is how the solid particles are held together. So what do you observe here in solid? It is tightly packed. So solid particles is tightly packed. And these individual particles, like those small circles, they cannot move freely. So if it is tightly packed, so the movement of particles, the particles move rarely. Like they don't move much. So its movement is very slow, or you can say very slow. The movement of particles is very slow. And how about liquid? So it's not as tightly packed, right? So you can say it's not as tightly packed. Then how about the movement? These particles can move this far. This one can move this far. It's like in an elevator, you are like 6 people together, right? So 6 people, they can if this person here doesn't like this person, it can go here, right, and ask this person to come here. So they can move with decent amount. So they can move little bit more freely than the solid particles. So the correct term would be movement of particle is more freely than solid. The last one is gas. So gas particles spread, the distance between gas particles are huge. Like they the packed least so it's least tightly packed, and the movement of particle is very high. It's like you leave a dog in your dog in there is only one dog in a dog park, and the dog can move anywhere it wants, right? They like to play. So movement of particle is very high, so they can move anywhere they want, right? So that's the difference between solid, liquid, and gas. So if you just remember this picture, everything's gonna be fall into place. And the last property we're gonna talk about is the attraction between particles. So what do I mean by attraction between particles? So you have 2 green dots, right? Maybe 3. So each particle is attracted to others. So that's why they are tightly packed. So the attraction between the particles is very high. Or I should call the highest. And obviously gas is going to be the lowest, right? And the attraction between in liquid, in between the particles in liquid, is gonna be in the middle between these two. So can you think of an example? Yeah, just say solid is ice, liquid water, liquid water, and gas is steam. So you can think of that way. So how can you convert ice to liquid water and steam? By applying heat. So that's what we're gonna be talking in the future. How can we convert amongst different states of matter? Okay, I'm gonna stop here. We'll get back to our next video in the future.